Okay, this is a review of systems of equations. Okay, there are four things we did in this chapter. First, we solved a system using the graphing method, then the substitution method, then elimination, and then we also solved systems of inequalities with two variables. Okay, so just a quick recap. Graphing method was just all about the intersection of the two lines. Okay, the intersection is the solution. Substitution is all about, just like it sounds, plugging something in. Plug in one variable into the other equation. Elimination is when you're combining the two equations in order to cancel out one of the variables. And the system of inequalities is all about where the shading overlaps. So, in a brief overview, those are the four things we're going to be looking at. Okay, graphing method, which is we're looking for the intersection. Substitution, we're plugging in one variable for the other. Elimination, we're combining the equations so that one cancels. And with inequalities, we're graphing and we're looking for where the shading overlaps. Alright, so first we're going to look at the graphing method. Okay, the steps for the graphing method. Step 1, graph both lines. Okay, you've got a system with two lines, you need to graph both of them. Step 2, find where they intersect. And that's it. The intersection is the solution. So, looking at this example, if we were going to solve this system, y equals 2x minus 4, and y equals negative 4x plus 2, I'm going to have to graph both of these lines and find the intersection. So, I'm going to start with the first line. It's in y equals mx plus b, so I know the y-intercept is negative 4, so I put my point down here. Then I know that the slope is 2, so up 2 over 1, so I've got my second point. Now usually that would be all the points I would use to make a line, but since I don't really know where these are graphing, I want to make sure I get a good straight line, and I'm going to go ahead and do my slope a few times. Up 2 and over 1, there's another point, up 2 and over 1, so I get a good range of points for that line. Then I can draw my line. Now for the second line, I see my y-intercept is 2, my slope is negative 4. So I start at the 2 on the y-axis, and I go down 4 and over 1. And when I do that, my point's right on top of that other point right there. I can see that's already obviously my intersection. I'm going to draw the line out just to finish it out, and I see that that is where the two lines cross. Now, the solution is where that point is. This point is at 1, negative 2. So that means that my solution is x equals 1 and y equals negative 2. And that's how you solve using the graphing method. Next method is substitution. Steps for substitution. First, you have to isolate a variable. Just any one variable, doesn't matter. The top x, the bottom y, the top y, bottom x, doesn't matter. Get one variable by itself. Then you plug the value of that variable into the other equation where that variable is. So if you get that x equals y plus 1, then you plug in y plus 1 in for x. Step 3, solve the equation you now have, because now you only have one variable. You can solve an equation with one variable. Then step 4, plug that variable that you just found back into the equation and find the second variable. Okay, so let's look at what that looks like. So if we were going to solve this system of equations, we have x equals 3y, x plus 3y equals 9, and you have x plus y equals 1. Okay, so first you've got to choose which one you're going to isolate. I'm going to go ahead and choose to isolate this x. Okay, just because these numbers are smaller, so I'll use this equation. And really I could have done the x or the y, either one would be the same, so I'm just going to choose to isolate the x. Okay, so that gives me x equals 1 minus y, because in order to isolate the x, I would have to subtract the y over to the other side, and I get 1 minus y. So now I'm going to take this value, what x equals 1 minus y, so I'm going to plug that value in where the other x is into the other equation. So then that gives me a new equation. That gives me 1 minus y plus 3y equals 9. And now I only have one variable. All I have is y's here, so I can do step 3 and solve, and I can figure out what y is. So first I've got to combine like terms. So negative y plus 3y is 2y. Then I have to subtract 1 from both sides. I get 2y equals 8. So then I divide by 2, and I get y equals 4. Now, step 4. I have to plug that value back in to the equation. Okay? So I'm going to plug the 4 in for y. That gives me x plus 4 equals 1. So I can solve that, subtract 4, and I get x equals negative 3. So my solution is x equals negative 3, y equals 4. Okay. Now I can always check my answer, and I could have checked my answer with graphing too. I can always check my answer by plugging these two values back into both equations. Okay, they should make both equations true. If they don't, then they're not the solution. If I plug in negative 3 plus 3 times 4 is 12, negative 3 plus 12 is 9, that's true. Then negative 3 plus 4 is 1, that's also true, so this is my solution. Now, notice, I plugged this y value back in up here. But that probably wasn't the best place to plug it in, because right here I already have the x isolated. So it probably would have been smarter just to go ahead and plug it into this y, wouldn't it? So then I just see that x equals 1 minus 4, which 1 minus 4 is negative 3. I wouldn't have had to solve this one algebraically if I would have used this one. Okay, but you can, as you see, you could plug it into this one, or you could have even plugged it into the other one. You can choose any of these three equations to solve for the second variable once you have the first one. Okay, and now elimination. Okay, step 1 on elimination is to multiply an equation or possibly both equations, by some number so that you have opposite coefficients on the same variable. Now, what does that mean? That means you could multiply one of them by a number like times 2 on the whole equation, or times 5 on the whole equation. But the whole idea is you've got to get opposite numbers, opposite coefficients on the same variable. So if you have like a 5x and a negative 5x, or a 2y and a negative 2y, okay, you need them to be opposite, one positive, one negative of the same number, and they have to be on the same variable. You can't have 2x and negative 2y. That doesn't do you any good. It has to be the same variable. Okay, so then step 2 is to add the equations together. Okay, step 2 only works if you've already completed step 1. Okay, because when you add the two equations together, then one of them is going to cancel out. One of the variables is going to cancel out. This will allow you to solve, because then you'll only have one variable. You can solve any equation that only has one variable. Okay, so then once you solve it, step 4, similarly to substitution, is to plug that value back into one of the equations to find the second variable. Okay, so we're going to solve this system. Negative 9x plus 3y equals negative 3, and 3x minus 2y equals negative 4. Okay, so my first decision is, what do I need to multiply? Okay, I could multiply both equations, or I could just multiply one. Sometimes you'll have to multiply both. If you can get away with just multiplying one, then that's less work, better for you. Okay, now I start looking over here at the y's. I'm not going to be able to multiply anything to just turn this 2 into a 3 or this 3 into a 2 unless I use fractions. And then I'm going to have fractions everywhere else, so that's probably not the best idea. But the 3 and the negative 9, that would be pretty simple, because I could turn the 3 into a 9 very easily, and then negative 9 and positive 9 would be opposites. Okay, so I'm going to multiply this equation by 3. So I'm going to do times 3 on that whole equation. So 3x times 3 is 9x. Negative 2y times 3 is negative 6y. And negative 4 times 3 is negative 12. Okay, now at this point, I don't need that other equation anymore, so I can kind of forget about it for a second. And I'm done with step 1, because I have a negative 9x and a positive 9x. Those are opposite coefficients on the same variable. So now I'm ready to eliminate. Okay, so step 2, add the equations together. So I'm just going to add straight down. Remember, you have to add the x's with the x's, the y's with the y's, and the constants with the constants. So negative 9x and 9x, that just cancels out. 3y minus 6y gives me negative 3y, and negative 3 plus negative 12 gives me negative 15. So now I've got a fairly simple equation for step 3, solve. All I have to do is divide by negative 3, and I get that y equals 5. Now for step 4, I need to plug that 5 back in. Okay, but where do I plug it in? Well, kind of like substitution. You can plug it in wherever you want. You could plug it into the top equation, here where the y is. You could plug it in to the bottom equation that you used. You could plug it into the original bottom equation. Any of those three is perfectly fine. any of those three will give you the same x value when you solve. Okay, so I'm going to use the top one. So I've got negative 9x plus 3 times 5 equals negative 3. All I did was take this 5 and put it right here where the y was. And now I have an equation with just an x, so I can solve. I get negative 9x plus 15 equals negative 3. So I need to subtract the 15. I get negative 9x equals negative 18. Divide by negative 9. And I get x equals 2. So now that I have x and y, I have my solution. So my solution is x equals 2 and y equals 5. Okay? And for the last thing we did on systems, solving a system of inequalities with two variables. Okay, this one is similar to the graphing method because that's the method we're going to use for inequalities. Okay, step 1, graph each inequality. Step 2, only keep where they overlap. Okay, and this is very similar to when we graphed compound inequalities with one variable and they had an and statement. You only kept where they overlapped. And a system is kind of like an and because it has to be both equations, right? So it's like this equation and that equation. That's why it only counts where they overlap. So we're going to use a graph to solve this system of inequalities. I have y is less than negative x minus 3 and y is greater than or equal to 3x minus 2. Okay, so I've got my graph and I'm going to graph my lines here. I can see that both of these are in slope-intercept form, so that makes them pretty easy to graph. My y-intercept is negative 3 and the slope is negative 1 at the top line. So I start off with my y-intercept at negative 3. I go down 1 and right 1 and get my next point. Now I can't really go any further in that direction, but since I want my line a little longer, I'm going to go ahead and go the other way. So up 1 and left 1. And I'm going to do it again. Up 1, left 1, up 1, left 1. And I can draw my line. Okay? But this line can't be equal to. So it's got to be a dotted line. Okay? And it says that it's less than. That means below this line. If you put your pencil on the line and move it down, that's the side you shade. So I'm going to shade below this line. Now again, you may be good enough at this point at this to not shade until you know exactly where to shade. But right now I'm just going to stick with the drawing both of them and figure out where they overlap. Okay, so now the second equation, or inequality. I have my y-intercept and my slope. Y-intercept is negative 2. Slope is 3, so 3 over 1, up 3 over 1, up 3 over 1, and I can draw my line. Okay, this time it can be equal to, so I leave it solid. And this time it says it's greater than. So I put my pencil on the line, and I make it go straight up. That's the side I shade, so I need to shade everywhere here. So I'm going to draw horizontal lines for this case. And I've got all of these lines. Now, as you see, down here, I have vertical lines, but no horizontal. In this section, I have horizontal lines, but no vertical. In this section, I have no lines at all. But over here in this section, I have horizontal and vertical lines. So this is the section where they overlap. That means I need to get rid of everything except this. This is my shaded area. So I need to go ahead and erase all this other stuff so that I only leave the overlapping area, because the overlapping area is the solution. Okay, so that's how we graph a system of inequalities and find the solution.